Welcome everyone to this week's IPLD sync meeting. It's October 21st, 2019. And as every week we discuss any things the IPLD dev team has, and we first start with updates from us and then going through any agenda items. This time I even have an agenda item. So I start with myself. So last week, so I'm still working on making 32 support tags. I don't know if it's my brain or not, but like I constantly forget how 30 works. And basically it feels like every day I try to remember how it works. And then I code something and then no, this doesn't work. And then why doesn't it work? And then I have no idea. Like if it's that complicated or if it's me, I have no idea. But I think I'm getting closer still. Besides that, also like on my, so it's not IPLD related, but I also work when I do Filecoin work, I do Rust stuff. So I'm getting better there on foreign FFIs, foreign function interfaces. If anyone has something in this regards in Rust, feel free to ping me and ask me for help. I think I've got good understanding, and also so I'm mostly working on the error handling. So if you have any questions.
What does Rust need that for?
Sorry?
What does Rust need FFI for? I thought it was the other way around. I thought Go was calling into Rust.
So basically Go calls into Rust, and so we expose an FFI. And the problem is that there you don't have all those safety guarantees anymore. So for example, if Rust panics, it just crashes and it's gone, and you don't want to do that. So you want to return a proper error and such things. So it's this way, Cool. Next is Eric.
So I've had a long week again. I'm still in areas that are not very far from where I've been in the last couple of weeks. It's fun. I've been doing lots and lots of research spokes into the performance that we can expect from the code that is created by the code generation in Go. And this is just a really deep topic, and it's very difficult to iterate on because it touches everything at once. I know a couple of things that are useful as high-level guidance from the previous experience with our reformed library, which does a bunch of serialization in Go in some of our projects right now. And the main thing that I know from that experience is that in making things perform well, the count of memory allocations, not the size, but the instance count of memory allocations is going to be one of the heaviest hitting things in holistic performance overall. And I also know from the hard way that redesigning things later to avoid this is tricky. So it's I've been trying to front load a lot of those efforts. I don't know if this is entirely wise, because it turns out as I try to do this, I keep having to implement surprisingly large amounts of the system in order to get the holistic picture. If I try to just optimize or build benchmarks for like one set of methods, invariably the benchmarks get extremely misleading, because I'll find out that, oh, the inliner was able to work on an example of this size, and the inliner enabled like 20 other compiler optimizations, very special. And if I scale it up, then none of that holds. And so trying to get to the truth in the bottom of these things is just very, very fun. So trying to figure out where to get rid of these memory allocations and how to design around that. It's also entangled with the maybe API design questions from the previous weeks, so that's fun. And I think at this point, the way forward is going to involve me just trying to build a table of figure out what the worst case is, and then figure out which cases are better and right trade-offs. I have yet to find a single solution space that is optimal in all cases. So it's just going to involve choices. Some of the worst case scenarios would involve having a memory allocation per node and per node builder in the entire tree. And that would be survivable, but it would not be fast. There's some optimizations that I can make to amortize like 2 of those down into 1 very consistently. But the trade-off is then the number of bytes taken goes up. And because of like specific details of the way the GC and the heap work in the Go runtime, it turns out that those additional bytes will then get held onto for the lifetime of the node rather than just the node builder. Maybe lots of applications will be able to ignore this, but it's not a free trade. So yeah, long story short, that's turning out really, really hard. I might have to beg for another pair of eyes to like help me tie break and make sure I'm not missing any spaces there. So yep, that's about it. And anecdotally, for saying it's hard, I did a completely different implementation of the way structs are code generated today, or this last week rather. So it uses no pointers instead of lots of pointers like the previous generation. I thought this would be better. It actually got slightly slower and took the same number of allocations overall for other holistic reasons. It's been a long week. In report.
Thanks. I have one comment in regards to optimizing Go stuff. So just be careful not to optimize that much for the Go garbage collector, because from like past experience from other teams I've worked with is that it changed in every release, and they basically ended up with needed to compile the whole system with 3 different versions of Go, because they worked around so much around certain things that in the new version didn't work anymore. So I guess my takeaway is perhaps test it with older Go versions, because you can't test with newer versions, obviously. But just like once you have benchmarks, just run with an older Go version to see if it's like kind of matches or if it's like completely screwed. Because that's just yeah. But I've only heard stories about it, so I wasn't involved myself, but I heard stories. But it was a huge pain. So, yeah.
So far, historically, most of my surprises have been when things got better and made some previous design choice look ridiculous in retrospect because there was a clearly superior solution instead of a series of trades. But
in their case, it was the other way around. So yeah, just keep this in mind. Okay, cool. Who's next on the list is Rod.
So I had a week that was not dissimilar sounding to Eric's, but certainly not as intense and serious. I spent most of my week in Go on the Go schema library. I'm spending a lot of time on it, and I'm sure it'll pay off eventually. It's not connected to IPLD Prime yet. I'm hoping to move it towards that so that we have a bridge between the two, so that you can read schemas in and do something and do code gen with them. And it's getting into shape, I think. And the tests are all now in sync as well between the two. And what I spent the week doing was one of those maneuvers like Eric's talking about, where you can't do it in small pieces. You have to do all of it. And so I refactored the data structures that hold the schemas to get rid of the Go maps, which just make me so angry. And so there's basically no maps in the Go schema library now. It's all lists and then custom JSON encoding methods to get them back into maps for JSON. And so now everything's ordered. It retains orders. And so now I can do the full test cycle where I'm reading a schema, testing the JSON version, and then turning it back into a schema again. And I can compare the raw schema text without worrying about the types jumping around between runs. And I mean, it just feels nicer just to have that stability and to get rid of the unpredictability of it all. But then I started doing some extra experimentation with some other things, and then just flamed out in anger. Part of it was discovering that there's no way in Go to read JSON and know what the order of the JSON parse was and what the order of the things are that came in, unless you write a custom JSON parser.
Which is why we have, right?
Which is why what?
This is one of the reasons that reformed library I alluded to as being a source of many hard lessons.
Right. I can imagine, yeah.
It may be irrelevant.
We use a one-up JSON parser in JavaScript as well, because we have to order the keys.
Yeah, but at least you can get to the underlying information. Like you go just. I read a thread.
You could parse everything with any parser, but for encoding we use it.
Right. So I read a thread that made me rage, and it was by some of the Go authors. And somebody was saying, I'd really like to be able to get to the ordering of the JSON parse. And they were like, no, what's your use case? Tell us a use case. I'm like, well, I want to do this. No, that's not a good enough use case. No, write your own. And I kind of get that. I get the inclination towards, like, they want to keep it simple and approachable, but it's just this, like, I don't know, it was an arrogance or something that just really annoyed me. And I was like, well, I have a use case. And you're telling me, they basically said, no, you need to fork the core library and do it yourself. Anyway.
And it just makes you feel like if that person who was asking worked at Google, it would just happen.
Right.
But because they don't, it's like not a good enough use case.
Apparently there are some extensions slated as a to-do for the core JSON encoding library to just some hooks to get into the process. But anyway, it was just came away with a bad taste at the end of the week. And to top it all off, I was talking with a friend who spent a bit of time in Go as well, and we ended up having the same things to rage about. But I'm not going to say that this is my final assessment of Go, because I fully understand that I'm at that stage, when I don't have the full sympathy for the language, and so things like I want to do much more object-oriented style, like I want to use inheritance properly. Go doesn't want you to do that, and so you have to think differently. And so I'm totally not over that hump of thinking like a Go programmer. And so my rage is more about it not working the way I want it to, rather than me thinking the way it wants me to. So anyway, it's a positive experience because it's all learning and everything. So just a bit of rage. So that's me.
Thanks. Michael, your update?
Yeah, so last week, at the very end of the week, I got all of the JSU Next Best stuff working that I've been like cranking on for a few months now. So this is like, you can basically encode directories, files, and the data, and we have the full sort of like big DAG possibilities with the data side of it. The data side ended up being sort of so complicated, but also fairly reusable and a pretty generic problem. So I broke that into its own spec, and that was sent to the specs repo called the data. I'm just calling it data for now. I'm not tied to any of the names, so if anybody has strong opinions about the names, just change them. I changed them. I changed them so much during development that I'm actually like just unhappy with all of them, and so I'm like a total pushover on this. Like, for the first person who decides what those names should be, is just going to win. But the underlying architecture is really nice because it means that we are no longer sort of taking a layout and tying it to like an actual like read code. So you can write basically readers for 3 advanced layouts, and then any changes that we want to make to how the DAG is actually constructed in the future, and change the algorithms and do flat or trickle DAG or whatever the hell people want to do, or like mutations over time, where you may have like a perfectly flat DAG and then you mutate it a little bit and stuff like that. All of that will just work with the same reader. So That's really nice. That means that we don't have to go and update the readers in every implementation because somebody decided to encode it slightly differently with a different algorithm. And of course, you can still sort of like encode the name of the algorithm that you used and stuff like that, so we can try to be compatible between different rebuilds of the same data. Anyway, so that works. That was a real pain. As a result, the IPLD schema gen library is pretty close to finished in terms of being completely feature complete. The architecture is really nice and stable now after the rewrite. So I'm really happy with that aspect of it. I feel like I'm getting a much better idea now too of how people will consume advanced layouts in the future via different programming environments. So there's a lot to learn there. Like, I think that the thing that you end up exporting from your library is the types. And we're not real, and like what's going to happen is that if you have a library for generating an API or doing code gen, then people will use that library to create some types and then hand them to somebody else who uses those types in their schema. So what you're going to end up with is schemas that refer to types that aren't in the schema, but they need to be there before it could actually generate an API, essentially. And you don't really have like dependent schemas because they are dependent on the code and the generator that you end up using, if that makes sense. Like the moment that you inject code into this, you can't really get away with just dependent schemas. You end up like needing the dependent code anyway. And so if you're consuming the code, you might as well just consume their types. And then your libraries for generating new APIs can just consume other types that you had generated previously. Right? Does that make sense? Okay.
I'd really like to see Eric get to this point of experimenting with it in Go and seeing what lessons overlap there. I can't wait for that, but it seems like it's a bit of a distance away.
Yeah. I mean, it'll be nice to see sort of like where the two end up landing, because there're definitely going to be some big differences. But I think that was like one takeaway that I had, where I don't need a way to import schemas from somewhere else. Like that's actually not useful because I have to get the code anyway. And like that's going to be super dependent on the programming language that you're using. And if somebody writes a different API generation library than mine, then they're going to have a different way to share the types and import the code. So yeah. Anyway, but eventually all of that will also be in a separate module. So all the data stuff will be in a separate module. So anyway, this is quite nice. I think that for the next few weeks, I'll probably write more tests and use what I have in terms of the UnixFS stuff for a small project in order to kind of put it through the paces before I bug the IPFS folks about it, because it's a bit ahead of schedule right now. And then I'll go and write some of the MFS primitives on top. I want to handle a lot of like, I'm not going to implement the MFS API from IPFS, but there's a lot of like you need a smart graph builder in order to handle concurrent changes to MFS. And that is something that we need to deal with in like a pretty generic way in IPLD and figure that stuff out. And I have enough experience with this stuff anyway that I can just write it and hand that off to the IPFS folks when the time comes. So anyway, that was nice. Another thing that I recognized, and this actually kind of sucks because it's not as nice. So in prior iterations of UnixFS, I would hand you like a generator. So you would say like, go and give me this directory, and you would get it back in generator and be all these blocks. And then at the very end, you would get the root block. And so it was a really clean generator that just always yielded blocks. That doesn't work anymore because the root node of what you create isn't necessarily a distinct block. So what you end up creating is a generator that yields blocks until it yields the root node, and then it actually gives you back essentially the instantiated type from the schema gen. But it could be the encoded version of that if we wanted to, right? But effectively, like, you need actually something that you could potentially inline into something else. So that really changed how a lot of the APIs look. Like they yield objects now that say block or root, and it looks a lot more like other more advanced generators that have like type variations in them. But that was an interesting thing to learn in terms of like how we can structure things, and it's not always just a clean like, hey, just always give me blocks, because to some extent I'm saying, okay, you figure out where the block boundaries are in the sub DAG, but then you need to give me back a root node that I can just inline into something. because it's not necessarily going to be a distinct block. So that was also an interesting thing that I learned doing that. And then I think that's about it. Yeah. There's a few things that aren't in Schemagen because I'm just not using them, and those will need to be added. Like renames aren't supported yet. Some of the representations aren't supported because I'm just not using them yet. But there's places for them to go in. It was architected sort of understanding that those would go in. I just haven't done the work to put them in now. So. Yeah, and that's about it for me.
Michael, you have 3 different block encoding, well, byte encoding things going on there. You've got, I think it's just plain bytes, byte list, and then a nested byte list.
So it's technically 4 because it's an inline byte linked to a raw block of bytes, a list of links, which is an inline list, not a linked list, and then there's any kind of nested DAG beyond that. Anything that is more complicated than that, and then that more complicated thing, the leaves that you end up pointing to are pointers back to that union. So within that big nested DAG, you could have, just a list of bytes that's simpler, right?
Do you have clear heuristics on what would make different layouts? Like I know you're saying that there should be flexibility to do it in different ways, but is that too much flexibility?
So it was too much flexibility until I figured out this recursive union thing. And that really simplifies it, actually, because once you wrap that in an advanced layout, you just have this recursive read call that happens through the entire stack. And it's actually quite simple. And it looks exactly how it would look no matter what layout algorithm you would end up using. So if you just have one, then this is actually kind of ideal. And if you have other algorithms, you can just plug them in. But yeah, I mean, we have some examples from IPFS where they have the flat DAG and the turtle DAG, which with GraphSync, we may not care about as much, but you still have the problem of I create a flat DAG or some kind of balanced DAG that I want, and then I mutate it. Like that happens actually all the time. Like there's a call in IPFS called write, where you just write a couple bytes in there. And so what you end up doing is traversing into it and then just mutating those few last little bits. And so if your read functions assume the layout rather than, assume the layout algorithm rather than assume the sort of type that they're bound to, you end up with this problem where every layout has to have a different read method. But if you just say, no, layouts just consume these same types, so the types have the read methods, then you don't need to do that. And you can mutate, you can make like really discrete mutations, and depending on how big those mutations are, they might, create another huge section of the DAG that's another nested DAG, or they might just like, mutate one of the lists and pop off a few things, or point one in another piece or whatever.
Okay.
But yeah, and then once you get into optimizing for different types of mutations, you're going to end up with a lot of different layout algorithms. I think that's the thing that's really going to explode them. Like the current layout algorithms are sort of hacks around the fact that we only had bit swap, and that it was really expensive to do these round trips into sub-DAG portions. But I think that once you look at, okay, I have a file that I'm only going to append to, and I expect to append to it often, that is just going to have, you're going to want a different layout. Like you're going to want to change how you lay out the data to really efficiently do those writes and to minimize the garbage that you create. And we don't want to have the reader get swapped out because you had that different layout algorithm.
Okay.
Yeah.
All right. I have one agenda item, which is only about the time of this meeting, because like in Europe, the daylight saving time ends soon. But it seems to me that, so for me personally, it would be great if we would just keep the UTC time, because then it would be 1 hour earlier for me. And probably in the US as well, but it's in the middle of the day, so I don't care.
I don't mind it being an hour earlier. It's just that I don't know what happens then when daylight. DST is going to end here too in November.
Yes, so basically 1 week afterwards. So basically, when your daylight saving time ends, it will be 1 hour earlier for you. And
In the same slot?
Rod had already his change, so.
Okay.
So in distributed meetings that don't like that span the globe like this, it does end up being easier just pinning to UTC. So there's no arguments, there's no preferences. Yeah,
let's just pin it, and then some of my other meetings I'll probably realize we're not pinned, and I'll have to change them. But yeah, if we can just alter the existing meeting to be in UTC rather than on a particular time zone, let's just do that.
Yeah, cool. Yeah.
Okay.
Excellent.
And
Yeah,
then
I think that means you need to change it to Reykjavik time.
No, it is already UTC. So it is pinned to UTC, and also on the so you can do it somehow. It took a while, but you can do it in Google Calendar somehow. Unless someone changed.
I see it actually.
So it should be pinned, and it's also in the README, so it should be fine. And if not, so I will take care of it that for the next time zone changes within the next 2 weeks that we stay at the same UTC time.
Okay.
Cool. It doesn't. It gets better for you though, doesn't it, Falco? You go earlier.
Yes, it gets better. Yeah, so it's earlier. So it's So basically, winter. So like the European winter. So October till March is easier for Europe, Australian.
Yeah, it's easier for us to cover, and then because we go 2 hours together, and then we go 2 hours apart.
And then,
yeah.
Exactly.
Wow. Fucking time zones, man. Yeah. And then just a general note. I'm here next week, but the week after that, I'm just out the whole week. And another thing. So the week that I'm back, the week before lab week, is like this planning week that they're doing. And so I'll have a template. There's a template. I'm going to work through it and try to figure out what our plan for 2020 is. And then I'll share that sometime this week with everybody. And I just need you to get in your feedback in the next few weeks so that I can finalize it before I leave. But it's going to be pretty simple. It's basically going to say like, look, we are working on getting things to a point where we get adopted in our direct dependencies inside of protocol labs. So IPFS and Filecoin. And then, we will learn from that and then from there grow our dependence outside of protocol labs. But I'm not going to lock us into a particular time frame because we need to have the ability to learn and iterate as we go. We'll see how that goes. Cool. All right. Awesome.
All right. Anything else?
I'm good.
Cool. Then I close the meeting. Goodbye, everyone. And so.